Hello students, I'm sorry about that. The video cut off right in the middle of me talking. I'm so sorry. I know, I'm trying to use this technology stuff. I'm still getting used to it, so please be patient with me. Again, the video cut off right in the middle, so I apologize. I think the place that the video cut off was right here on step 2. And as I was saying, if our group is less than 30, we can only do the problem if the word problem says it's a normal distribution. But what if it's under 30 and it's not normal? So if it's under 30, the size of our group is less than 30 people, and it's not normal. And some examples of not normal are skewed left, skewed right, uniform. So if it says you have a group of 22 students and the distribution is skewed left, what do? Then you cannot do the problem. The problem cannot be done. You just write can't be done. If it's under 30 students, let's say you have 16 students and it says it's in a uniform distribution, then you're right, can't be done. So these are the 3 categories or the 3 rules that make up the central limit theorem, and the central limit theorem only applies to groups of items, groups of people, groups of students. All right, so once you get all this and once you realize if you can or cannot do the problem, then you need to find the mean and the standard deviation of the group. Here we go. The mean of the group is equal to the mean of the population. The standard deviation of the group, because remember the subscript x bar means group, the standard deviation of the group is equal to the standard deviation divided by the square root of n, the square root of the sample size. So if you can do the problem, this is how you find the mean and the standard deviation of the problem. And don't worry, you know me, we'll do some examples of this on the next couple of pages. So pick up your lecture notes, and here we go. Let's begin. In 5.1 and 5.2 and 5.3, you found the probability of an event for an individual person or a single item. But what if you wanted to find the probability of an event for a group of people or a group of items? This is called a sampling distribution of sampling means. This is just a fancy and confusing way to say group. So sampling distribution of sampling means group. Properties of sampling distributions of sampling means. In other words, properties of groups. The mean of the group is equal to the mean of the population. The mean of the group is equal to the mean of the population. The standard deviation of the group is equal to the standard deviation of the population divided by the square root of the sample size. This is also called the standard error of the mean. I think they might use this terminology in your homework. I'm not sure. Note, the distribution of sample means has the same mean as the population. These are the same. If this is 50, this is 50. If this is 68, this is 68. If this is 10, this is 10. But its standard deviation is less than the standard deviation of the population. The standard deviation of the group is less than the standard deviation of the population. This tells you that the distribution of sampling means has the same center. The middles are the same for both the group and the individual, but they're not as spread out. So the group is going to have a smaller standard deviation. The group is going to be tighter about the mean. Also, the distribution of sampling means becomes less and less spread out, tighter concentration about the mean as the sample size increases. So again, let's review our central limit theorem. For a population with any distribution, doesn't matter. If the group is over 30, the size of the group is over 30, you can do the problem no matter what. And here's your mean and here's your standard deviation. If your group is under 30, but the original population is normal, you can do the problem. Again, here is your mean, here is your standard deviation. And the third rule of the central theorem says if you're under 30, but it does not have a normal distribution, if it's skewed left, skewed right, or uniform, skewed left, skewed right, or uniform, can't spell, then the methods of this section do not apply and the problem cannot be done. And there is, sorry, I shook the table, and there is the first page of our lecture notes. Let's turn the page. Here we go. Let's actually do some problems. Page 1. A study analyzed the sleep habits of college students. I'll make sure The study found that the mean sleep time was 6.8 hours with a standard deviation of 1.4 hours. So 6.8 for the mean, a standard deviation of 1.4. Random samples of 100 sleep times are drawn from this population. So we're going to pull out a group of 100 people and record their sleep times. Our group is the size of 100. So here is our N. Find the mean and standard deviation of the sampling distribution of sample means and sketch a graph of this, all right? So the mean of the group equals the mean of the population. These are the same, and the mean is 6.8. The standard deviation of the group is equal to the standard deviation of the population divided by the square root of n. The standard deviation of the population is 1.4. divided by the square root of 100, which is, pick up a calculator, turn it on, it's clear, 1.4 divided by, your square root button is over here in a color, so you have to activate it with the second button, second square root of 100, hit enter, and you should get 0.14. Now, how do I draw a picture of this? Remember the bar in the middle. Oh, I keep shaking the chair. I'm so sorry. The line in the middle is the mean, which is 6.8. And then we're going to go up 1, 2, 3, 1, 2, 3. And the new width of our bar is 0.14. So we're going to do 6.8 plus 0.14. So that bar is 6.94. Add 0.14 again. This bar would be 7.08, and add 0.14 again and get 7.22. To go to the left, we subtract. So you're going to do 6.8 minus 0.14, which gives you 6.66, minus 0.14, 6.52, minus 0.14, 6.38. And there's your first problem. Let's do another one. A study analyzed the sleep habits of college students. The study found that the mean sleep time, again, 6.8, standard deviation of 1.4. Random samples of 64 sleep times are drawn from this population. Again, we're good because it's over 30. Find the mean and standard deviation of the sampling distribution of sample means. Again, remember those big long words just means group. Find the mean and standard deviation of the group and sketch a graph. So here we go. The mean of the group equals the mean of the population, which is 6.8. The standard deviation of the group equals the standard deviation of the population divided by the square root of n. The standard deviation of the population is 1.4, but now we're dividing it by the square root of 64 because now I'm taking groups of 64 students. So I'm going to do, in my calculator, 1.4 divided by the square root of 64, and you should get 0.175, 0.175. To sketch a graph of this, the mean goes in the middle. 1, 2, 3 bars up, 1, 2, 3 bars down. I'm sorry, I keep shaking the phone. 6, let me get my calculator in here. 6.8 plus 0.175 gives you, I'm going to turn my page this way, 6.975 plus 0.175 gives you 7.15 plus 0.175 is 7.325, and there's that side. Now we got to do 6.8 minus 0.175 and get 6.625 minus 0.175 is 6.45 minus 0.175, 6.275, and there's the answer to that page. At this time, I'm going to stop the video. Just be patient with me. I'm going to load up another video so that it's easier for me to load on YouTube. So take a quick break and I'll be right back in just a second.